Hello everyone. Welcome to another video of Controllers Tech. As the title says, today I will cover the FreeRTOS again, and this time, it's the timers in FreeRTOS. This video is divided into two parts. The first part will cover the usage of timers using the CMSIS functions, and in the second part, I will use the pure FreeRTOS functions. You can check the timing for the respective parts in the description of the video. The first half of the video, where the setup will be done, is common for both the parts. Let's start by creating the project in Cube IDE first. I am using STM32 F446RE controller. Give the name to the project and click Finish. In the Cube MX, I am enabling the external crystal for the clock. Now before we go into timers, I will explain about them a little. So basically there are two types of timers in FreeRTOS. Auto reload timer, and the one-shot timer. Once started, a one-shot timer will execute its callback function only once. It can be manually restarted, but will not automatically restart itself. Conversely, an auto-reload timer will automatically restart itself after each execution of its callback function, resulting in periodic callback execution. Now let's enable the FreeRTOS. In the parameter setup, enable the timer's usage. Timer priorities can vary between 0 to 6, keep it at 6, so that we don't have any problems regarding something preempting it. Leave everything as it is for now. If you are watching this video for pure RTOS functions, then you don't need to do any other setup for the FreeRTOS. The remaining setup for the FreeRTOS is only for those who wants to use the CMSIS functions. Go to Tasks. Here you can see the default task is already created. Let's give it some better name. I will call it UART task. Priority normal is fine. Task function will also be UART task. So we can't have same names for both. It's okay now. Let's create another task. This will be LED task. I am keeping the priority same as the UART task, so that they don't interfere within each other's operations. Task function will also be the LED task. The tasks part is done here. Let's create the timer now. I am naming it periodic timer. The callback function will be PT callback. Here you can select the type. I am keeping this one as periodic. Let's create another timer now. I couldn't came up with any better name for this one. Anyway, this will be a one-shot timer. Other parameters are kept as it is, and this completes our FreeRTOS setup. I have PA5 connected to the onboard LED, and that's why I am setting it as output. Also the user button is connected to the pin PC13, and that's why I am setting it as input. Now enable the UART, so that we can send some data to the computer. Also, since we are using FreeRTOS, we need to change time base from SysTick to any other source. Let's see the clock setup now. I have 8 MHz clock, and I want the system to run at 180 MHz. This is it for the setup. Click Save to generate the project. So this is our main file. Here are the task handles, and the timer handles. Then we have the task functions, and the timer callback defined here. Inside the main function, first of all the timer is created. Here is the name of the timer, and here is the type. The callback is declared in the timer's definition. Next part is where the tasks are created. We have already discussed about them in the previous videos. Now here is the function that will be executed when the UART task will be called. As you must have noticed that we haven't started the timers yet, we have only created them. So here, when the control enters the UART task, first thing we are going to do is start the periodic timer. I am writing this outside the infinite loop, so that it can only run once. OS timer start takes two parameters. The first one is the handle to the timer that you want to start, and the second is the time duration for the timer. This timer will expire every 1 second. Now we will send some data via the UART. And this task will keep running every 2 seconds. The periodic timer will time out in 1 second, and the callback function will be called. In this callback function, we will send another string via the UART, indicating that the string is sent from the callback function. Before writing the LED task, let me explain its purpose. So basically, if the button is pressed, the onboard LED should turn on for some particular amount of time. This will be an implementation of timeout feature for the LED. We will first check if the button is pressed. If it is, then turn on the LED by pulling the respective pin to high. And now we will start the one-shot timer for the period of 4 seconds. In case you want to change the period of the timer during the runtime, you have to call the timer start function with the new time period. Note that the timer start function also acts as a timer reset function. So, if the timer start is called before the timer is expired, it will reset the timer again. In simpler terms, if the button is pressed before the LED timeout, it will extend the timeout by another timer period. Once the timer is expired, the callback function will be called. And here we will turn off the LED. Let's build this now. We have few warnings, and they are because of the data types there. I will leave them for now. Let's debug it. I am using Hercules to monitor the UART data. Let's run it now. You can see the timer string is printing every 1 second, and on the other hand UART string is printing every 2 seconds. Let's press the button the controller. The LED turned on. And it turned off after 4 seconds, just as we programmed. But if we press the button before the timeout, the LED will never turns off. You can see the UART task and the periodic tasks are performing just fine, and they are not affected by other tasks and timers. This is it for this video. I hope you understood the usage of timers in FreeRTOS, using the CMSIS functions. You can download the code from the link in the description. Next half of this video will cover the same, but by using the pure RTOS functions. I am assuming you have already gone through the setup in the first part of this video. First of all, we need to copy all the header files from CMSIS file, and paste them in our main file. Now delete all the pre-generated CMSIS functions. Now let's start by creating timer handles. PT handle is for periodic timer, and OT handle is for one-shot timer. Now we will create task handles. You can see the handles for the UART task, and the LED task. Now we will write the task functions. Let's start with UART task. When the control enters the UART task, first thing we are going to do is start the periodic timer. I am writing this outside the infinite loop, so that it can only run once, since the timer is periodic anyway. Xtimer start takes 2 parameters. First is the handle of the timer. And second is the time to wait, before starting the timer. Since we want the timer to start immediately, I am writing a 0 here. Now we will send some string via the UART. And this task will keep running every 2 seconds. PDMS to ticks basically converts the milliseconds to ticks, as per the FreeRTOS setup. This completes the UART task function. Let's write the LED task function now. Before writing the LED task, let me explain its purpose. So basically, if the button is pressed, the onboard LED should turn on for some particular amount of time. This will be an implementation of timeout feature for the LED. We will first check if the button is pressed. If it is, then turn on the LED by pulling the respective pin to high. And now we will start the one-shot timer immediately. The period for the timers is set during their creation. The LED task will run every 20 milliseconds. This completes the code for the task-related functions. Once the timer is expired, the timer callback functions will be called. And that's why we need to write a callback function now. We can write a common callback for all the timers, and that's what I am going to do. Let's call it timer callback, and its parameter will be the timer handle. If the callback was called by the periodic timer, we will send this string to the UART. And if it is called by the one-shot timer, then the LED will turn off. Note that the timer start function also acts as a timer reset function. So, if the timer start is called before the timer is expired, it will reset the timer again. In simpler terms, if the button is pressed before the LED timeout, it will extend the timeout by another timer period. Now let's write our main function. We are going to start with creating the timers. xTimerCreate takes the following parameters. The name of the timer, here you can give some random name, as it doesn't matter. Second is the timer period, and I am keeping it 1 second for the periodic timer. Third parameter is to set if the timer is periodic, or the one-shot timer. True means periodic, and false means one-shot. Fourth parameter is the timer ID, and you can assign any ID to this timer. Fifth parameter is the callback function for the timer. Similarly, we will create another timer, with minor changes in the parameters of course. This will expire in 4 seconds. It's not a periodic timer, so PD false. And give a different timer ID. We also need to equate them to their respective handles, since the xTimerCreate function returns the timer handle on success. This is all for timers. Now let's create the tasks. xTaskCreate takes the following parameters. First is the task function. Name of the task, again the name does not matter, so use whatever you want. Next is the stack size, and I am keeping it 128, since it was set in the CubeMX also. Next is the parameters, which we will keep as null. Then the priority, which I will use as 1, for the normal priority. And the last is the handle for the task. Similarly, create the LED task also. This completes the task creation. Now in the end, start the scheduler. Let's build it now. We have 2 warnings here, and we can remove them by changing the data types. Okay, we are all set now. Let's run this program. I am using Hercules to monitor the UART data. You can see the timer string is printing every 1 second, and on the other hand UART string is printing every 2 seconds. Let's press the button on the controller. The LED turned on. And it turned off after 4 seconds, just as we programmed. But if we press the button before the timeout, the LED will never turn off. You can see the UART task and the periodic tasks are performing just fine, and they are unaffected by other tasks and timers. This LED is similar to the backlit for the display, or any other device, which can be controlled by the timeout feature. We have other functions available also. X timer change period can change the period of the timer at any point. This is to delete the timer. Reset is to reset the timer, but X timer start can also be used as the reset, if the timer is running. Just like we are doing here, whenever the button is pressed, and the timer is still running, this will reset the timer, and it will start from the beginning. You can check out these functions. This is it for the video. I hope you understood it. You can download the code from the link in the description. Keep watching, and have a nice day ahead.